This is task 2 and our question is to find out the best fit function of the form f is equal to a times p raised to the power b using the least squares method. So here the f represents the flow rate of a fire hose and the p is representing pressure, and the unit for P is PSI and the unit for F is gallons per minute. So we are given some data points here which we'll use to find out the constants A and B, and we'll transform this data so that we can use the linear regression formula that you saw in task 1 to find out the constants A and B here. So let's start working on this one now. So just explaining the formula a bit more. So this is about a fire hose where the flow rate is equal to a constant A times the pressure P raised to the power B, another constant. So the flow rate is in gallons per minute and the pressure is in PSI. So we are given the points already, and the first thing we can do to go to the linear regression formula is consider this we'll make this into logarithms. So we'll have ln of f is equal to ln A plus B times ln P. So here the ln f, we can say it is some constant which is z, and we can say ln A is our A naught and B is our A1 and ln P is W. So this now is the linear regression line, which is A0 plus A1 times W. So we'll now work out to find out A0 and A1 here, like what we did in task 1. So trying to again write down the formulas to find out the values we'll have here. So we have here ln A is equal to A0, which means that A is equal to e to the power A0, and then B is directly A1, so we don't need to do anything for that, and A1 we'll take the formula directly from the linear regression. So we have n times the summation of Wi Zi minus summation of Wi times summation of Zi divided by, so I'm not writing here the I is equal to 1 till n. It's not, it is good to write it. Let's write it. So here then we have n times summation of Wi squared minus the summation from I is equal to 1 till n of Wi the whole squared. And we also know from the linear regression that A0 is average of Z minus A1 times average of W. Alright, now let's work on our table for all these terms. So that's exactly what we did for the task 1 linear regression. here the values of pi, fi, and then wi, and then zi, and w times zi, and then we'll have wi squared. Okay, so we have here pi, fi, wi, but wi, if we look behind, so we need to find out here wi zi, wi zi, wi squared, right? So wi is nothing but ln of p, right? So it's ln of pi. And then we need to find out the zi, and zi is nothing but ln of fi. And then we have to multiply wi by zi, and then we'll have to take each wi and square them. So we are already given the points in the question at the beginning. So here we have, for p we have 10, 16, 25, 40 and 60, and for the flow rate we have 94, 118, 147, 180 and 230. So let's write them down first. So we have here 10, 16, 25, 40 and 60. And the f of I is 94, 118, 147, 180 and 230. And if you calculate the natural logarithm of log to the base 10 of p of I, which is 10 here, you'll get the values here as 2.3026, 2.7726, 3.2189, 3.6889 and 4.0943. And then for zi, if you calculate the natural logarithm of the values of the fi here, you will get 4.5433, 4.7707, 4.9904, 5.1930, 5.4381. And then if you multiply the wi here and the zi here, so if you multiply these two values, you will get 10.4613, 13.2271, 16.0636, 19.1562, 22.2654. and then if you square each value of the wi, which is equal to ln of pi, you will get here 5.3019, 7.6872, 10.3612, 13.6078 and 16.7637. So now we need to do the summation, but here in this case we don't need the summation for pi and fi for whatever values we have here. So we don't need the summation of pi and fi, so we'll leave that and calculate the summation for the rest. So here we have for the summation of wi, we have 16.077 24.935 81.174 and 53.722. So once we got this, now we'll put these values to the formula for A1. Let's copy the formula for A1 that we have here. So now we will replace these values here. First, we need to know what is our n. So how many points do we have here? 1, 2, 3, 4, 5. So n is equal to 5 here. So we have 5 times the summation of wi times zi, which is 81.174, minus the summation of wi, which is 16.077, times the summation of zi, which is 24.935, and this whole thing will be divided by n, which is 5 times summation of wi squared, which is 53 times 722, minus the whole of wi squared, and that is 077 squared. This gives you the value for A1 as 0.4910. Now let's calculate the value for A0, which we know already is z bar minus, or the average of z minus A1 times the average of w. So the average of z, you will get the total of z, which is 24.935, divided by the number of terms here, which is 5, minus we have A1, that is 0.4910 times w, the summation of that, which is 16.077, divided by the number of terms, that is 5, and this will give you the value 3.4083. So we got the values of A1 and A0. So in that case, now we can write our linear expression. Or we could write it in the same page here. So we have our linear expression, z is equal to A0 plus A1 times w. So we have A0 is 3.4083 plus A1, that is 0.4910 times w. So that's the linear expression, but that's not what we want to come to. That's not our final answer, right? So we need to find out the values of a and b constant. So a as you know it already, is e to the power a naught. So e to the power a naught, that is 3.4083. So that a is equal to 30.213. So we got the value of a here now, and we already know b is just equal to a1. So b a1, the value is 0.4910, so that's the value of b. So now we can write our equation in the form f is equal to a times p to the power b. So we have f is equal to a, that is 30.213, times p to the power b, that is 0.4910. So this is our final result. Now if someone says you to find out the flow rate at a pressure 22.5, let's say, then you can put it in this function or equation that we got just now, which is 30.213 times p, which is 22.5 to the power 0.4910. So you'll get the answer as 139.4 gallons per minute. That's the end of task 2.